Alright, so first we'll warm up with a coding bat exercise. I don't think I walked through this with you on Monday. When we work with 2D arrays for coding bat, it's a little bit different because there's some limitations when creating 2D array problems on coding bat. So we'll do the first one together as a class. countFives. So you should bring up your coding bat exercises. Be sure to sign in, unlike myself. countFives. So going here, it says using nested loops in row column order, count and return the total number of fives in 5x5 grid of ints. Click on the hint button for the code for the local 2D array variable. So notice our function here, its input will be nothing, and we return a number, and there's only one test case. Okay, so here's what I don't want to see. I don't want to see you just give me return 7 and then pass, right? I'll go in and give you a 0 if you do this. You should be copy and pasting the array from the hint, paste, okay, and then writing in the 2D array code that walks through this array and counts and gets you to 7. Okay, pentagonal number and count digits has been requested. We'll see if we have time for that today. So from countFives, you should be doing something like this, writing your nested for loops. I think there's a little template in the slides. I and j, I less than grid dot length, I plus plus, and then here of our j loop, grid square bracket I dot length semicolon j plus plus. Then in here, you gotta make a counter. Answer equals answer plus 1. And at the end of it all, you return answer. So something like this. All right, I need to see this kind of code be given, even though there's only one test case and you know there are going to be 7 fives inside this 5x5 2D array. Oops, do something wrong. Oh, I forgot to check. Right, this one just counted everything, so I got 25. If the number that you're at, grid at I guess kind of like indices, I comma j. If you're equal to the number 5, then you add stuff to your answer. There we go. So 7. So no excuses. Here's straight up the answer. If you click on CR solution, they'll even give you an example for that. Copy and paste it if needed. At least go through the motions. Don't give me a return 7. And I'll check this by randomly choosing like 10 out of you, right? Out of like 40 people. 10. If anyone does return 7, then I have to go back and check you all. So don't be that person. I'll publicly shame whoever does return 7 after I told you explicitly not to. Fair enough, right? Questions or comments? Okay, so that's the first part. A little bit about the coding bat because it's a little different. We'll do another coding exercise as we're implementing and using 2D arrays. Here is a 10 by 10 multiplication table. While I'm talking, you should open up processing. We're going to code this up together. It's pretty short. So starting with the first row, we print out the numbers 1 through 10. Writing a for loop for that is simple enough. And you should be seeing that nested loop idea in the later rows in this multiplication table. As the second row, it's everything multiplied by 2. Then the third row, it's everything multiplied by 3. In the fourth row, it's the first row times 4, so on and so forth. So we'll put a loop inside another loop that multiplies it. For the first line, this is going to be our innermost loop, as that is the stuff that gets repeated. You have the example code in red that starts counting at 1 up to 10 plus 1. Notice the use of print here, not print line, and this special character is the tab that has things evenly spaced out, so it looks nice. And then I should go back here, right? Let's go through the motions of bringing this up in coding that first. We have our outer loop, and you have 2 lines of code or little bits of code that are missing. What should go into those question marks? And you have hints in the comments. So in a moment, I'm going to reshare my screen and go over what would be placed into these question marks to get this multiplication table outputted. It's not processing even opening. It is. I have to reshare my screen. Alright, let's see, stop sharing, share my screen, desktop, share. Okay, so there's my processing window. Copy and paste this bunch of code. Go back to my processing, paste it here. So previously this was just what, NJ, and then this one, I guess we'll leave as a comment for now. We'll have a peek at the output. It's going to be off. I think it's going to make just one big number of 1 through 10 repeated. Yeah, so it's not very evenly spaced. This thing I think is all one. Actually, let me double check. Let's make my window bigger. Yeah, so it wants to just keep using one line and it spills over for the output. Not exactly what we want. I mean, one step to get closer is to figure out what goes here. This blank should take care of the new lines that happen. Right after you hit 10, after your first loop is done, you should press the return key. So the equivalent of doing that is system.out.print line, nothing inside. Okay, and this should fix that formatting issue. Although we still see the numbers 1 through 10 a bunch of times, 10 times. Nice. We have a nice little grid here. We need to do some extra multiplication that happens. So from this one, you guessed it, we type in ni here. Both variables, both counters from our loops must be used. Press run, and ta-da, there's our pretty multiplication table. Using these indices, hopefully you typed out these for loops too, these nested for loops. Questions or comments? Alright, save that for later. And so slide 29, it gives us that exact answer. So in these next couple slides, we'll go over, what is it? Do we need this? Can I skip it over? Yes. So emphasizing the use of nested loops. Here's another example using the character array, the alphabet that we worked with on Monday. Our first loop, notice the alphabet.length, like how I did grid.length. No, I didn't even use grid.length here. I guess it was in the countFives example. We want you to use alphabet.length here. Don't hard code it to be 4. It's bad practice. This is the length of your arrays of arrays. There are 4 smaller arrays inside one big array. Notice this part here, another pattern. We don't want you to hard code this at all to be like 7, as you see that the 4th array here is only of size 5, right? Cause index out of bounds if you were to not use alphabet square bracket r.length. This adapts to the size of your inner arrays. Okay, so definitely get used to this pattern using .length to get the size of your big and small arrays. So as a short practice quiz question, you can copy and paste this into processing and get it to print out this sentence: the quick brown fox jumps over the lazy frog, with this 2D array of strings called words. Or you can click on this replit link, which will do the same thing. It has the code written out for you. Okay. Can I copy and paste it? Yeah. I'll even copy and paste it into chat so it's easy for you. More practice with 2D arrays. And I'll give you maybe a minute and a half to do this problem. Another 30 seconds, and then I'll go over the answer. You'll know you're right if you see the quick brown fox jumps over the lazy dog. Alright, let's go over the answer. I'm going to copy and paste this into processing and comment out the stuff about the multiplication table. Shrink the output window because we don't need all that. Paste in this code. This 2D array is nicely spaced out, so you see that each of the arrays do have different size. The first one is 4, next one's 2, and the last one is 3. Should emphasize the point that you should be using .length. Rows, r starts at 0. We go into the length of our large array called words. We add 1 each time. Starting at 0 for the columns. We go up to, r is less than. This one, c is less than. Words square bracket r dot length c plus plus. Oftentimes, some mistakes that will be made here is misusing the variables. Right, make sure you have R's in all three places. And for this one, make sure you have C in all three places. Don't forget to use the outer loops variable here to walk through the size of the individual arrays. So I think with these two loops filled out, they should give us that sentence. Yep, there it is. The quick brown fox jumps over the lazy dog. Oops, jumped a little bit too forward. Okay, second part of class, we talk a little bit about your Game of Life assignment. Tentatively, it is due next Friday. Depending on how people do on it, we may give you a bit more time. And in the Game of Life, we use a graphical user interface known as a GUI. So you've seen these a lot before. When you go to a web page, it's a GUI. When you use different applications like games or Google Docs, that's all GUIs. Checkboxes, sliders, text fields, and buttons, where users interact with them. And they aren't built into Java or processing, unfortunately, but we can borrow the capabilities of making a GUI, interacting with a GUI from a library. And the specific one we're using is called Guido. Guido in and of itself is a little joke. Guido. And so adding it, we must first open processing. Okay, these steps are a little bit extra. There, you could just use Replit to do this assignment, and that works where all the libraries are already imported, but maybe you want to be fancy. I'll show you how to add the Guido library or any other library you want to use to processing on your own computer. Okay, first you got to open up processing, wherever that is. Once you have that open, like I do here, I think in which one? Where are you? Yeah, Sketch. Okay, so on Macs it's on the upper left-hand corner. Sketch, import library, and we're going to need to add library. You can see I already added Guido to my processing, but if you're doing this for the first time, up here, add library. So once you click on that, new window will appear, and you can see all the different libraries that processing can support. We are specifically looking for Guido. So you type in Guido, and you can see Florian Jeanette. This is the one we want, Guido, a simple cross-mode GUI library, not the one from the author, Guido Kramen. So once you click on this, make sure it's highlighted, click on Install. It's a rather small library, shouldn't take that long. Install. Give people a minute to do that. Okay, the slides 36 through 39 walk you through those steps. Here's another image of what we clicked. And we found Guido. Sketch, import, add. Type in Guido. Find Guido by Florian Jeanette. Okay, assuming that you're set up with Guido, that is on your own processing. If you plan to use the Replit, then you can just chill out for a bit. Once you've added Guido, we want to make sure that it works. And the Guido library comes with some prepackaged code to ensure that it is in fact working. So go back to processing. Go under File, I think. Click on Examples in the menu. under contributed libraries, expand that folder. There will be a Guido folder. And inside are some example code. We will click on button. Okay, double click, will open a new sketch, which shows you examples of how they make buttons. The code that we're going to work with is very similar to this. I have slides going over it, but for now, just press play. To see that you properly added Guido, you should see a grid of gray buttons. And when you click on it, they change colors, showing you they have been clicked. If you click on them again, they turn back gray. The buttons have like this toggling feature, which you'll need in your game of life assignments and for those willing to take on the challenge, your Minesweeper assignment. Okay, this is how you know it's working. Right. So for clarity, to make sure our Guido is working, we opened up an example, file, examples, opened contributed libraries, opened Guido, double-clicked button. So there's a picture of what you should see. Guido, adding it manually, we'll skip over that. There shouldn't be a need to, given the new, given that you're running the latest version of processing on your computers, or even like any version that's like 3 and above, I think. Back in my day, I think we may have had to physically add in these libraries. So we'll walk you through some of the parts of the code you need to know for your Game of Life assignment. So the important part is that inside the Guido class, they define a button class, which we'll be utilizing. And that's highlighted in yellow here. Here is just the button class. Notice they have certain features. They have X and Y coordinates, I think still of their upper right-hand corner, upper left-hand corner, because they're rectangles, and they have width and heights, a Boolean that holds in whether or not it's on. I guess it's clicked or not. Here's its fancy constructor that tells it where to go, its width and height. And then this line of code is the one that looks funky. It does its own thing. Interactive.add this, register it with the manager. I'm not quite too sure what this does, but it has to be there. Notice that this line, mouse pressed, that should be familiar. You used it in your create your own fractal or your Sierpinski triangle assignment. On equals not on. Okay, if you are on, then change your value to to your opposite. This is toggling. Draw. This stuff looks familiar. Gray background, buttons. Boolean is on, return on. Sure. Here's how we use the myButton class. Notice at the very top, you must declare it. Then you must make this manager thing. This line of code has to be there. And here you create a button. MyButton equals new MyButton. This is a call to the constructor we just reviewed. Once that's created, the button will be on the screen. And inside draw, we'll give it that fancy behavior. In this case, when we click on it, we will see that the text appear button is activated. So if I copy and paste, I guess this code right here in slide 45, this code should show us one button appear onto the screen, and when we click on it, it will say text activated or button activated. Click, yep, button is activated. Now to get some practice with this Guido library, we're going to have you make a second button. and the rule changes slightly. We want you to show the text only if both buttons are activated or pressed. Having just one of these buttons being pressed is not enough to display this text. So please modify this code, add on to it, to get this desired output. Alternatively, you can go to this replit. Everything's already set up there. Go to button practice, modify the code that does the same exact thing. I guess I'll go to the replit this time around. Show what that looks like. With the remaining time in class after this, what I got like 5 minutes? We'll try to go over one of those coding back problems that were requested. Give people 2 minutes to modify this code and I'll go over the answer. Okay, I'll review the answer in another minute. Okay, I'm going to go to the replit. Did I already fork this? Guess I'll just fork it again. Once I fork it, you should be able to see some code. Don't know whether or not it's the file we want to modify. First time you run things on replit, it may be kind of slow. It's improved greatly since a year ago. Main.java is not where we want to be. We want to be in sketch.java, I think. We want to see the Guido code. Yep, there it is. So I made my text a bit larger. And the lines get spilled over. There we go. Yep. Okay. So first off, we need to make a new button. We must declare another my button. Let's call it my button 2. Or button 2. No space. My button, button 2. Next, we don't need to add another manager thing, interactive.make. Just need to do that once. Button 2 equals new my button. Let's have it at position 220, 190 for the Y. We'll make it of size 30, 30. 25, 25. Slightly bigger so we know that it's there. Okay. Then we can see that second button being created, right? Let's do that before modifying the if statement. Press run, be patient for its output window to appear. We should see two buttons. Yep, there's two buttons. One that has that rule tied to it. If it is pressed, then it's activated. My second button just clicks. No behavior is associated with it yet, and it's slightly bigger, so I know it's different. That the bigger one is button 2. Then we modify the rule. Looking at this example, we will add in, since both buttons need to be activated, an AND statement here. Button 2 is on. Then you can modify the text. Both buttons are activated. Stop. Closes this. Press run. Give it a moment. We see our two buttons. Clicking one doesn't show the text, but clicking both of them, both buttons are activated. Woohoo, success. Toggle one of them off, it disappears. Neat. So knowing how to create buttons, interacting with them at first should get you in the first like 7 or so steps of the Game of Life assignment. I did this in less than 10 minutes, and then this other stuff is where it gets complicated from steps like 9 onwards. That's the implementing the rules of the Game of Life. It's a pretty neat simulation of like modeling life. You may see this by biology people, Conway's Game of Life later. I think it's significant in biology as well as math. So that's all for today's lecture. Student that requested pentagonal numbers and count digits, feel free to email me and I'll offer you some hints that way. And if there's time on Friday, we'll definitely save and go over those 2 coding bets. Formally, you're all dismissed. Have a good Wednesday. I'll see you on Friday. Email me if you need help, set up office hours.